Good morning, everyone. Welcome to Introductory Chemistry lecture. In this chapters, our focus will be on writing chemical reaction equations, and we'll do some calculations. Okay, also known as stoichiometry. Okay, first of all, before we do that, we need to have some background. And when you look at the period table, you will see what we call atomic weight, and I'm going to show you a quick one right here. You will see a small number and you see a big number. The small number usually on top, but it can be anywhere. Okay, the larger number is on the bottom. I know it's got small here. The okay, so let's take a look at for example. You got the idea. Okay, for example, look at boron here, for example. You see the small numbers is number 5. That's the atomic number. The large number, that's what you're looking at. The average, the weight average atomic mass, okay, or atomic weight. That's 10.81 for boron, okay, 12.01 for carbon. Okay, so you got the idea. That's called the atomic weight. Now we go back to the lecture here. Atomic weight is the average, the weight average, like I said, on the periodic table. And for an element, it's also known as atomic mass, and it's going to be gram per mole. Okay, so for carbon, it's 12.01, and that's gram per mole. All right. Now, remember 1 mole. There's 2 ways to look at mole. One is the quantity, and the other one is the mass. Okay, so the mass, you look at the periodic table, and you got the atomic mass. Now, how about the quantity, right? 1 mole is how many atoms or molecules, and that's a fixed number. It's 6.022 10 to the 23rd. 1 moles of a compound or element, the quantity always the same. Just like when you say 1 dozen, it's always the same. The 1 dozen is 12. 1 mole is always 6.0 10 to the 23rd. Formula units or atoms or molecules. So it's a huge numbers, okay? But then when you do mass, it's going to be different because it depends on what substance you talking about, right? For example, water. 1 moles of water is 18.02. That's 2 different things. One is we call formula mass, and the other one we call molar mass. They are the same numbers, okay, just different units. So you take a water, you can see 2 hydrogens plus 1 oxygen. So you look up the mass of water, of hydrogen and oxygen, sorry, and then hydrogen is 1.01 and oxygen is 16. To multiply it by 2 for hydrogen, add the oxygen, you get 18.02. If you do formula mass, it will be AMU, which is known as atomic mass unit per molecule. That's 18.02. If you do molar mass, it's the same idea. It's just in gram. And this is more popular unit because we're going to be using molar mass to do the conversions, which is the next one. So you see here I put a note here. Formula mass and molar mass are the same in quantity, but only different in units. Okay. Okay, so here we're converting mole to gram and gram to mole. Okay. For example, carbon. You have 2 gram of carbon. Now, how do you convert that to moles? Okay, and then you look at the periodic table. It's 12.01. 12.01 mole. All right. Now let me show you how to do that. So notice, okay, if you have to print out or something to take notes, it will be a good time. Okay, so let me show you the whiteboard so I can show you how to do that. Okay, so you got 2 gram. You got 2 gram, 2.0 gram of carbon, and this is how you set it up. And you have 1 mole, okay, and then how do we know that 1 mole of carbon is 12.01 gram. Okay, and like I said, how you know that? You look on a period table, and then you cancel out the ram, and you get mole. And you put in your calculator, I believe you get 0.017. If you keep it to you keep it two significant figures, okay, 0.017. So you guys want to take a minute and check it out. If you route it off, 0.17, sorry, okay, 0.17. So 0.17. Okay, cool. All right, and so that's the first one. Okay, now I'm going back to. Okay, now I'm going back to the lecture here. Okay, so that's the answer. Well, similarly, you try for water, and remember, water, 1 moles of water is 18 grams. Right here, we did that calculation up here. Okay, so instead of just hydrogen or oxygen, it's combination of 2 hydrogen and 1 oxygen. So I'll let you guys try that. And CO2, to figure out molar mass, first you add a carbon, 12.01 plus 2 oxygen, and oxygen each is 16. Okay, so why don't you guys try those, and then we can go over them, okay, later. Okay, so those are the mole concept, converting gram to mole and mole to gram. That's one of the important part of this chapters. The second important part is the chemical calculations, okay? And but before we do chemical calculation, we need to know the chemical reaction equations and writing equations. You write equations, there's a product side, reactant side, and a product side, and you balance it. You make sure they balance. Okay, so now I'm going back to the whiteboard, and I'm going to show you the balancing equations. Okay, so for example, if you take like a CH4, okay, that's a gas, alternative natural gas, methane gas. You react with oxygens, okay, and you get CO2. This is known as combustion reaction. So you always get those two, CO2 and water, for compound with hydrogen and carbon and hydrogen only, okay? You get CO2 and water. This is known as hydrocarbon. Okay, cool. Now, to balance, it's very simple. Okay, so that's called chemical equations. On this side is the reactant side on the left. And then on this side is the product, okay? All right. Now, balance means you make sure they're equal, okay? So you're counting. You have 1 carbon on the left side, on the reactant side. You have 1 carbon on the product side. So we're good for now, okay? 4 hydrogen on the reactant side, but here you have 2. Now you cannot go around and change that number, because that's the fixed number subscript for that formula water. So you can't fix that, okay? But we can add the number in front, known as coefficient. You multiply it by 2, and that will make it a 4, and also it's multiplied by the oxygen as well. So in this case, you got 4 hydrogens, okay? 4 hydrogen, 2 times 2 is 4, and you also get 2 oxygens. Okay, so you got hydrogen taken care of. You got 2 oxygen plus 2 right here. That make it a 4, right? 2 plus 2, 4. But you only have 2. So if you go ahead and multiply it by 2, you're all set. And you got yourself a balanced equation. If there's nothing in front, it means 1. So you have 1 CH4 plus 2 oxygens give you CO2 and water. Now, it would be nice if you label them, okay? if we know the phase of the substance, like gas, okay, if you know this is a gas, you label them, and everybody knows CO2 is a gas, okay. Now water, usually combustion reaction happen at high temperature. Water is a liquid, but in this case, it's a vapor, or also known as a gas, because it's a high temperature, hot. Okay, that's called balancing equation. And I do have a few practice one for you to try, okay? So now I'm going back to the lecture right here. I have a few for you to try and also identify the type of reactions. Here we have either combination, when two substances combine together, decompositions, breaking apart from one compound, break apart into components, single displacement, when you have one single element displays another element in a compound, and so on and so forth. And the main focus is first focus on the balancing equation first. Check every single element, make sure they're equal, and then we can talk more about it. Okay. All right. So we'll continue in the next lecture. Okay. We'll talk more about the reaction type, and then we'll move on to the calculations. All right. Thank you, guys.